All right. Now we'll be looking at heart control. We're going to be looking at the systems that control the heart and the important stuff that we really have to look at. Now, before we get into really heart control, heart function, we have to have a talk about certain stuff. Now, we know that the heart is a muscle, right? We know that it's a muscle. So, yeah. So, for heart conduction, right, this huge, like muscular organ, right, really works off of electrical conduction, right? So, it is really electrical signals, right? So, electrical signals, right? That it really works off of, right? So these electrical signals travel through our heart conduction system, right? That and it causes it to expand or contract. So when we were looking at pressure, right, within how it changes on Vickers diagram, right, we're looking at systole and diastole, right? It is really caused by this. Ideally, this type of electrical conduction system, right, can actually give us or really keep us at a steady heart rate, right? So it really controls our heart rate, right? So it slows it down and it speeds it up, right? And we're gonna be looking at how it really does that or when it really does that, right? So let's start talking about the first part of the system, right? Let's start talking about, yeah, here. I chose this diagram so it could manipulate where, right, the stuff are in the diagram. So let's talk the sinoatrial node. Now, the sinoatrial node is actually found within the upper left quadrant, right, of the right atrium. So using that black spot to show it. Now, this is the sinoatrial node. So it really speaks to a bundle of cells, right? So it's a bundle of specialized cells, right? So it's really a bundle of cells. So this special bundle of cells, the SA node, right, SAN, right? So this special bundle of cells really are sometimes called our natural pacemaker cells. So pacemakers, right? And they send electrical impulses, right? So you see all the electrical impulses are sent throughout the heart. It really starts here. So the SA node, right, is really located right here. And it's a part of your autonomic nervous system, right? It's a part of the autonomic nervous system, right? So let's just see. It's a part of the auto. Oh, let me fix that. Right, so it's a part of the autonomic nervous system, right? So this means that it's really by itself, it really occurs by itself, right? It really gives the impulses by itself. So it starts all of these impulses, right, on its own. So it's auto, right, nomic. So it controls how fastly, right? Well, it speaks to, it's a part of it, right? So the autonomic nervous system itself really controls how fast or how slow our SA node sends electrical signals, right? So it's a part of it, right? I would say it's a part of it because it really controls it, right? So this part of our of our nervous system, right, as we said, really controls what our heart rate is doing, right? Now, the autonomic nervous system, I really need to speak about this. So the parts of the autonomic nervous system that I like to talk about, right, will be about the sympathetic nervous system. Nervous system. So the sympathetic nervous system, right, it really initiates our fight, right? Our fight or flight response. It's a part of that, along with adrenaline, right? So it makes your SA node work faster, right? So it allows the SA node to work faster. So the SA node works faster. The SAN is faster, right? So it causes it to go faster, and that will increase your heart rates. The heart rate will increase. But if we see here now that the parasympathetic nervous system takes control, right? Nervous system. So parasympathetic nervous system, right? So it really speaks about it usually is there in the rest and digest type of thing, right? So when you're resting or digesting, it is the parasympathetic nervous system is working, and it works to make your SA node, right, slower. So it makes it slower, right? So you gotta know that. Let's say node works slower, and we're gonna have a decrease in heart rate. Well, rate decreases. So with the sympathetic nervous system, right? Once you get started or your fight or flight response or you're exercising, the parasympathetic nervous system causes the SA node to work faster, increasing the frequency, right, of which the electricity really goes to the heart, making the SA node faster, making heart rate faster. And parasympathetic, right, slows it down, right, making heart rate decrease, right? So we've really stated here that the SA node, right, causes that initial thing, right? So it's a pacemaker cell. But let's look at this now, the atrioventricular node. We're gonna talk about the atrioventricular node a bit, right? The atrioventricular node now is a bit interesting, right? So the atrioventricular node actually accepts. So let me show the SA node here. So this is SA as we looked at a while ago, the SA node, and then here now would be the AV node. So electrical impulse goes here, the AV node, atrioventricular node, right? Now here at the AV node, the AV node actually delays electrical signal, right? So it delays it by around 0.1 seconds. So we're gonna have this delay. So it's really a fraction of a second each time. So this delay, right? This delay ensures that the blood empties from the aorta. Right? So that's one thing I need to mention, right? I think I forgot to mention a bit up here. When the SA node fires, it actually causes the atria to start contracting, right? So it is what causes the atrial systole, right? So it causes them to start contracting, right? And then the AV node delays it by around 1 second, right? To make sure that enough blood enters the ventricles. Because you don't want a lot of blood to be in the atrium and then contraction stops. So it keeps it going, right? So if contraction stops, it can cause a heart murmur, and we're gonna talk about that a bit, probably in a different video. So the delay ensures that the blood empties from the atria, right, before contraction stops, right? So we have that there. Our AV node here, we already established where it is, right? Now the next part of the cycle, right? Our next part of the cycle. We are now at the bundle. Right, this is an important bundle. Writing's a bit off right now. The bundle of his. Right? So the bundle of his. Now, the bundle of his is also called the atrioventricular bundle. Right? So let's relabel here. Right? Could you tell me what that is? Right? And here, what the name of this is. So we have those. Right? And then remember the delay, the delay that happens here. So this is the SA node. And then this is the AV node here. And then the electrical impulse actually travels here through a bundle of fibers. Right? And this is in the septum. So this bundle of fibers is called the bundle of His. Right? So the bundle, the BOH, I call it. Right? So the BOH, the B of H. So the bundle of His is here. So this is the bundle of His. Right? So the bundle of His is just a bundle of fibers, right? Electrical conducting fibers, a part of the heart's electrical conduction system, right? And it's found within the septum there. The bundle of His runs down the length of that of the interventricular septum, right? As we note there, the left part of the bundle of His really sends signals to the left to fibers within the left part of the heart, and the right branch of the bundle of His says stuff to the right part of the heart. I'm gonna know what those fibers are called. You can probably guess it before, right? So that is it. The bundle of His really acts as a interventricular, right, highway. That's what I like to describe it as. Right, so that's the bundle of His. Here now, let me draw back everything real quick. I'm doing this for repetition. I could have had a diagram that has them already, but I'm doing this for repetition. AV node, electrical current goes to the AV node, then it goes to the bundle of His. Right, so the bundle of His, B of His. Right, but now we have to note that there are going to be branches. So there are going to be branches. So the bundle of His, which is a large bundle of fibers, really now break up into these tiny fibers here. These fibers are what we call, let me label it up here. Right, so these fibers are what we call Purkinje fibers. Purkinje fibers. Right, so these are what we call Purkinje fibers. So these branch off the specialized nerve cells, right? So these are branches of specialized nerve cells, right? So they send the electrical signals very, very quickly to the left and the right sides of the the left and the right ventricles, right? Now these are what we these are in the subendocardial surface, right, of the ventricle. So it's within the walls, right? So we have that, right? So that is a type of surface that is called the endocardium. So it's located in the endocardium, right? So these are the Purkinje fibers, right? So our P fibers, our PFs, you could call it that, right? And these are found in the endocardium. The endocardium, right? So we have that there. So it's the inner layer of tissue that lines the heart chambers, right? So Purkinje fibers will deliver these electrical signals, right, to our ventricles and cause ventricular contraction. Isn't that cool? Ventricular contraction. So we're gonna see that, right? So we have that there. So as they contract, blood will flow into the pulmonary arteries and the aorta, right? And we looked at all of those that we talk about, right, within the other video speaking about Wigger's diagram, right? Now, yeah, so that's it, really. So, yeah, that should be it. So, if we can recap, we're just saying that the signal starts at the SA node, right? The SA node is connected to our autonomic nervous system, right? Which is has a sympathetic part, and a parasympathetic. Sympathetic nervous system really takes over through the sympathetic nerve, right? When impulses are carried to the SA node through that, then it increases the SA node action, right, and increases heart rate. If we have a parasympathetic interaction, we're gonna decrease heart rate as the SA node works slower. SA node is really found up here in the upper left quadrant of the left atrium, right? Well, of the right atrium, I mean, right? Here we're gonna look at the atrioventricular node, right? We see that atrioventricular node delays this, right? So remember that the SA node starts contraction, right? Atrioventricular node, right, actually starts it delays it. That delays contraction from finishing, right, to allow blood to enter the different ventricles. Then here now the bundle of His will conduct the electricity, and then after electricity travels to the bundle of His, it will go to the Purkinje fibers, right, causing ventricular contraction, right? So ventricles will start to contract, right? So we're going to look at, probably in another clip, we're going to be looking at what these electrical signals do within polarization, depolarization, and hyperpolarization when we talk about reading an ECG, right? So we're going to be looking at reading an ECG in the next video. So that was it. If there are any issues, right, with my content, right, you guys can just leave a comment, right? This document though, I'll save this document, right? So for anyone who's watching this that is in my WhatsApp group, right, I'll see how best I can get this to you, right? Just comment for it, right? Just tell me that you need it and I'll see how best I can arrange it. All right, so that's it.